When I made my first game, I made an object pool from scratch. I released the game and then found a much better way of doing it, which is what I'm using now, and we'll look at that today. Welcome to my devlog. I'm Simon, a senior creative from London's post-production industry who's moved into the world of indie game development. These devlogs discuss the systems I use and the thinking behind them. When I made Combat Search Rescue, I was having a problem with frame rate drops whenever I instantiated an object into the scene or deleted it. So things like bullets, every time I created the bullet, the frame rate would drop, and every time I deleted the bullet when it was finished, the frame rate would drop. Same with the enemies. If I instantiated an enemy into the scene, the frame rate would drop. And this is because the system was accessing the disk, loading the data it needed, and then it was building it. And it had to do that all in the space of one frame. And it couldn't, so it was losing and skipping frames. Now, there's an obvious solution to this. It's called the object pool. And what that does is you load all your objects at the beginning of the game, where the frame rate doesn't matter so much. And then when you need them in-game, where the frame rate does matter, you just move them out of the object pool and then move them back. Now, back then I knew the theory of object pools, but I didn't know how to create one. So I clumsily worked my way through and wrote my own in C#. It fixed my frame rate drops, but caused lots of other problems along the way. And I was fixing bugs with my object pool till the very last day. Now, the funny part of the story for me is, on that last day I did some reading and discovered that Unity had put in an object pool of its own in 2021, and I just hadn't found that when I was doing my research. I looked at their system and it's much more elegant than the one I wrote, but I was way too deep and I was about to launch my game, so I wasn't going to re-implement their object pool. So I'm now looking at it for my next game, and it's surprisingly easy to use. So let's take a look at my prototype with the object pool in action, and then we'll pull it apart afterwards and see how it works. We start off with a bootstrap scene called Splash Quick, and all that does is it takes control of the screen, puts a graphic up as quickly as possible so the player's not looking at a black screen. That loads the object pool, which is a separate scene, which loads all the objects into the object pool. Once we are loaded, we can then load our game, and then we're in the game, and you can see all the trees are being spawned into the game over a period of time. So all these assets you're seeing are just placeholders. I've not done the artwork for the game yet, and they've all come from the object pool. And the trees are an asset from Unity's asset store. Let's have a look. So we have the first scene, which is called Splash Quick, which is just a bootstrap scene. Like I said, it takes control of the screen, puts a graphic up, and it'll probably start playing music at that point. So the player has got something to see and hear while the object pool goes. Then there's this script that just says, load the next scene, which is the Splash Pool Builder. In here is where the object pool is. That's all it's going to do, is it's going to build the object pool and then load the next scene after that. This is what I call my manager object for the object pool, and all the object pools are in it as children. And they've all got a class attached, which is an interface of iObject pool. This code here is the object pool, and that's pretty much it. Let's have a look at the Unity documentation first, shall we? It's using UnityEngine.Pool, and all the classes are in here, and I'm using object pool. So you create the pool, and Unity allows you to create custom methods for each action. So there's a create pool method which you can program in yourself there. You've got a onGetFromPool method. So when somebody calls an item from the pool, it runs whatever you put in here, and I've just gone and set active to true there. And more importantly, on release to pool, when an object goes back to the pool, the object pool calls this method, and this is where I get to program the resetting of the object. And that's why I've got so many separate pools with the class of their own, because this will be different for each. Now, there's probably a less clumsy way of doing this instead of having multiple classes. But it hasn't occurred to me yet. But if it's occurred to you what I'm missing, do let me know in the comments, because I'm still learning C# and I am still getting to grips with all the quirks and all the patterns and things that I can use. So in my object pool, I created an interface, and in the interface, I've got a coroutine for building a pool of objects. I want it to build the pool when I want it to, but you don't have to use that. It will just build the pool as you call the objects, but I want it to build it at the beginning so I don't get the frame drops in the game. And these interfaces make it easier for other classes to send objects they've got references to back to the pool, instead of the pool having to call them or the object having to do it. The interface makes it easier. So as you can see, I have pool of diamonds, pool of coins, 4 different types of tree and a file, and I then have this script which pre-warms each pool one at a time, and it's quite simple. It just makes an array called collection of pools, and it fills that array by finding the interface iObject_pool in each of the children, and then it just iterates through each one in the list. It calls that coroutine, start the coroutine, pull the objects. So when this coroutine is called, it has a reference to a default capacity, which is how many objects I want in that pool. So it just iterates through and instantiates the objects and stores a reference to them in an array. And then once it's finished, it then takes the array and then releases them back to the pool. Now I did this because if you instantiate the object for the pool and then release it and then it asks for the next one, instead of building up a pool with multiple objects, it just keeps giving you the first one back over and over. And that's not what I wanted. I wanted it to build the pool. So what I do is I instantiate the amount I want and then I release them all in one go, so I've got that many in the pool and I know I've got them. Once we've iterated through the array called collection of pools, we wait for 3 seconds just so I can talk about it, and then we invoke the event, which then triggers the next scene to load. The important thing here is that I've got control over how many I can instantiate per frame. At the moment it's 1 per physics frame, or fixed update is the real word. I call them physics frames to remind myself what the function of a fixed update is for. So right now it instantiates 1 per fixed frame, and as you can see, here's the object pool manager filling this one, then it's filling the next, and it's putting in 1 object per frame. When it's finished, it loads the next scene. And then fetching objects from the pool happens in this prototype level. So here's my level. It's empty at the moment. So I have spawn objects with an amount I want, Gaussian spawn. Gaussian spawn just creates X, Y, and Z values for a vector 3 location for the object to be when it's spawned in. And the Gaussian random is a function I found on the internet called a Box-Muller transform, which is basically a standard deviation curve. So it will cluster the trees towards the center and there'll be fewer towards the edge, so they taper out and the forest can thin. I used it in my previous game, I've just recycled it. It's a long time ago since I did A-level maths, so it's familiar to me, but I'm not quite mathematically sound enough to remember how to write this formula. So I just found this on the internet and I've cut and pasted it in, and it works very nicely. Here's my level. And there you can see it's spawning in 400 trees, and they tend to be clustering around the middle. So you can see they taper out towards the extreme values of X. And that's all that Gaussian spawn does. The Y value currently is just set to 0 because my world is flat at the moment. It won't be, but I will cover that later. And Z is just a random range between a minimum and a maximum distance from the camera, just to give it some depth and control that depth. Well, that's just a random number. So once we have generated X, Y, and Z coordinates for my vector 3, we check that, make sure it's clear of others. Every time I put a tree into the scene, I'm storing its vector 3 in a list. So the list is called spawn positions, and what it's doing is it's going through each of the stored positions, and if the vector 3 we have isn't near any other tree, it will add it to the spawn positions list for next time, and it uses the prefab appears location when it fetches the prefab from the pool. For every prefab that's going into an object pool, I've added a pooled object script. And the pool object script is on all of them, and it just saves a reference to which pool it came out of. So when it gets released, it knows which pool to go back to. And if anything wants to release that object for it, it can ask it, what pool were you from? And then it can send it back to that pool. That's all that does. So that's what we're fetching. Here we're just using an array to the tree pools, and it selects one randomly. And then the random pool is then asked for its pooled object called spawned item, and it returns it. And then once we've got the poolable item, we set its parent, and we use the XYZ coordinates as its spawn location. And in here I could put rotations and blah blah blah, and that's all it does. And believe me, that's a lot simpler than the original one I wrote, because I had arrays holding things, I had lists and queues and all sorts of things, and I was getting in a right mess. I made it work, but it wasn't at all elegant like this Unity one. So that's how the Unity one works. And the only reason they're all on a separate class is purely for this on-released pool, because each prefab will have its own release method. So it will need its vector 3 location resetting, its rotation. Some will have particles, some will have physics that will need resetting, and some will be objects that have exploded, so all their shards will need putting back. They're all different. So that's the only reason I've got a different pool for each object, is because each object needs a different way of resetting, and I can't think of an elegant way of doing this without having a separate class for each. Now, if you know of an elegant way of doing this, please do let me know in the comments, because I'm still learning C# and I'd love to know what the clever way of doing this is. But for now, it works, and I'm happy, and I'm not going to touch it until I learn some more. The next video, you'll see my data persistence system, which also accesses the object pool, so I can save the tree positions and load them back, and that is something I want to be able to scale up, save the position of everything and load them back. Until that video, see you next time.